Okay, today we're going to continue with the trigonometry we did before. Let's just quickly review yesterday's stuff. We looked at basic trig ratios, the sine, cosine, tangent, and we talked about using SOHCAHTOA to help us remember the formulas. So remember with SOHCAHTOA, the first one is sine equals opposite over hypotenuse. Cosine was adjacent over hypotenuse. And tan was opposite over adjacent. So those are going to be what we're going to continue with today, but what we're going to look at is word problems and problems that have multiple triangles, so we can kind of use them in combination. The other two things that we're going to look at today is that might come in handy for solving some of these problems is we can always, because it's a right angle triangle, and remember if we use ABC as our triangle, remember we can always use Pythagorean theorem. A squared plus B squared equals C squared. So that's a valid formula to use when we're solving triangles. And the other one that will come in handy is when we know a triangle, it doesn't matter whether it's a right angle triangle or not, but in this case we have 90s. We know that the other angles, so the 90-degree angle plus that angle, they all have to add up to 180 degrees, right? All triangles add up to 180 degrees. So we have our three SOHCAHTOAs, we got Pythagorean theorem, and we got the 180 rule that we can all use for any of these questions if we need to. So let's go through, basically today we're just going to look at doing some examples, and let's go through a few different ones just to sort of remember what we did yesterday, plus to look at some harder ones. So this first example that's on this page is sort of a tree diagram. So you can see here the question is, what's the height of the tree? And we have the angle 25 degrees, and we know that we're 20 meters away from the tree. So if a word problem is given to you, sometimes you have to draw the triangle, sometimes it'll be given to you, but regardless, you can usually sketch it out okay. The one key thing to remember here is they talk about the angle of elevation. So whenever you see the word angle of elevation, it's always measured from the ground up. So if you were to draw your triangle like this direction instead, it doesn't matter how you draw it. So the angle of elevation will be 25 degrees. We want the height of the tree, and it says we're 20 meters away. So it doesn't matter which way you draw the triangle, it'll be the same calculation either way. So just like we did yesterday, the trick is which one are we going to use? Are we going to use sine, cos, or tan? So what you want to do, remember, is always start with the angle that you're given. So if we have 25 degrees, label your sides of the triangle. So the H in this case is our opposite. The hypotenuse we don't know, right? That's not given to us, so we don't know anything about the hypotenuse. And then the one beside the angle is our adjacent, and we should be good. So we have opposite and adjacent, so that means we want to use the tan formula. So tangent of the angle, so tan 25 equals opposite over adjacent, which is 20 in this case. So our adjacent is 20. Alright, so there's our formula. So the question is, how do we solve it? So remember, when we're doing these, you want to cross multiply, so we can put that over 1 if we want. So if we cross multiply those two, we have h times 1, which will just be h. We don't need to worry about the 1. And cross multiply those two, we have 20 times tan 25. And I'll put that in brackets so we remember that it's being multiplied. And do that on your calculator. So 20 times tan 25 gives us an answer of 9.3. If we round it off to one decimal place, 9.3 is good enough. And there we go. So we have a height of 9.3. So that's our height of that tree, is 9.3. And like I said yesterday, remember, always kind of go back to your triangle to see if it makes sense. So if our distance here was 20, does it make sense if that side's 9.3? Yeah, looks good. So that's a good answer. Okay, let's try another one. So this one, it says we put a brace up against the wall. They give us the brace is 8 feet long, and it says the bottom of it's 2.4 feet away from the wall. And the question is, what's the angle? So we're looking for that angle up at the top. Okay, it doesn't matter whether it's in feet or meters or centimeters or whatever, just ignore the units and just carry them on if you need to. In this case, the feet doesn't make any difference. So Using our angle, let's label our triangle again. So the one straight across will be our opposite, and the 8 in this case will be our hypotenuse, right? Because that's the one that's across from our 90-degree angle. Adjacent would be over here, and we don't know anything about it, so we're not going to use that part of the formula. So which formula has opposite and hypotenuse? It is our sine. So sine was opposite divided by hypotenuse.
Mrs. Jones, please contact the office.
So we'll have sine theta equals opposite 2.4, hypotenuse is 8. And remember to solve these on your calculator. Then what you want to do is go second sine. So go shift sine, and then put in 2.4 divided by 8 in brackets. And hit equals. And our answer is 17 degrees. Okay, so all these questions, same process over and over again. You want to make sure you figure out which, label your sides of the triangle, the opposite, adjacent, hypotenuse, figure out which formula, plug the numbers in, and then solve. Let's do a couple multiple triangle ones just to sort of show you that you can do harder questions, and it's just the same thing, just more than one step. And you'll see. So let's go with this one.
When you're done, please go to room 123. Thank you.
So question 4 here on here, it says calculate the measure of angle ABC to the nearest degree. So ABC.
110, Eric, and then 210, and then 123. Thank you.
So ABC, we're looking for this angle right there. So from A to B to C, there's our angle we're looking for. So we'll call that, we can call it X or theta or whatever, it doesn't make any difference. Let's call it theta, just so we have it. And we're ready to go. So if we look at that angle,
Mr. Warrock, please call the main office.
That would be our opposite. This one is our adjacent. And that one is our hypotenuse. So we're looking at that triangle. We've got our angle. We have nothing else. We just got that 12-meter hypotenuse. So this triangle by itself, we can't do nothing because we only have the 12. We need more information. Okay? So there's our angle. 12 isn't good enough. So now what we're going to have to do is look at the other triangle. So let's move over to this side and see what we can figure out. So we've got our angle of 35. We've got a hypotenuse of 10. So based on that, we could figure out the other angle if we wanted to. We could figure out this side, the BC side, or we could figure out the DC side, whichever. So what you want to do in a question like this is kind of think about, okay, what would we find that would help us solve the other question? So if you look at this one, what is shared between the two triangles? That would be the BC side. So let's call that side X, solve for X, and then that should probably help us figure out the other triangle. So using the X one, we've got opposite. X is our opposite. We've got our hypotenuse for 10. So that should mean we want to use sine. So let's go sine 35 equals opposite over hypotenuse. Okay, let's cross multiply. So we get X equals 10 times sine 35. Do that on your calculator. So 10 times sine 35 is 5.74 if we round it off. Let's keep our decimals accurate for the time being. So we know now that this side that's connecting the two triangles is 5.74. And now we can go back to our first triangle and we should be good. So this angle that we're looking for, now the 5.74 is our adjacent side, and the 12 is still our hypotenuse. So now we have adjacent and hypotenuse, so we should be able to solve this triangle now using cosine. So cosine of the angle we're looking for is the adjacent, and that's the 5.74 we just figured out, and our hypotenuse was 12. And we can do that on our calculator. So go second or shift cos, 5.74 divided by 12. So when you do that on your calculator, shift cos, 5.74, don't forget the brackets, 5.74 divided by 12, we get 61 degrees, and we're done. So you can see with multiple triangles, just usually means you got to do 2 steps. So when 2 triangles are touching, usually the trick is to find that side that they both share, and once you have that, then you can usually solve the rest of the question. Here's another one. So we've got 2 triangles touching, but in this case the question is, what is side x? What is the whole length of the bottom? So you can see with this one we really just have 2 separate triangles. So if we could figure out this side on the bottom here, let's call that one side A. And then if we could figure out side B on that triangle, it would make sense that x is just going to be those 2 sides added together. So this one's pretty straightforward. Basically just do the same thing and then determine which formula it is to use for each. So this first one, we got 40 degrees, we have A as our opposite, and 25 is our hypotenuse. So opposite and hypotenuse would be sine. And we can solve that one by cross multiplying. So A will equal 25 times sine 40.
Mr. Wilson, please call extension 123.
So 25 times sine 40, do that on your calculator, and that gives us 16.1. Now what we want to do is basically the same thing, but solve it for B. So when we use the other triangle, B is our opposite, 25 is our hypotenuse again, so it'll be basically the same formula, except 60 degrees is our angle, so sine 60 equals B over 25. When we cross multiply those, we get pretty much the same thing. So 25 times sine 60. Okay, so go 25 times sine 60. And that gives us an answer of 21.7 if we round it off. And that's it. We're pretty much done. So we know this side is 21.7. And the first one that we figured out was 16.1. We want to add those together, so then our total answer for x will be 21.7 plus 16.1. And that gives us 37.8 as our final answer. Okay. This one here, same sort of question like we just did the previous one, where we have 2 triangles side by side. So this one, if you look at it, you can see we've got side x is what we're looking for, but once again we don't have enough information, so what we're going to have to do is look at the first triangle, use the 45 degrees, and like before we want to figure out what that touching part is, so let's call that side A. So that'll be our adjacent side, and we've got our hypotenuse, so we should be able to figure out side A just by using cosine. So cos 45 equals A over 8. Cross multiply those. 8 times cosine 45 gives us 5.65, 5.7. And then once we know that answer, just like we did before, we can find the other triangle. So using the 60 degrees now, the 5.7 is our opposite side, x is our hypotenuse. So sim setup, except because it's opposite and hypotenuse, we want to use sine. So sine 60 equals 5.7 over x. Cross multiply, and remember in these kind of cases we looked at yesterday, when the x is on the bottom, it's sometimes a good trick to flip those around, so you can write it as x equals 5.7 divided by sine 60. And do that on your calculator, and we're done. So 5.7 divided by sine 60 gives us 6.6 if we round it off. So 6.6 is our answer for that one. Let's do one more, a little bit more difficult. So you can see here it's sort of a triangle within a triangle, and we're looking for just side x, which is just this piece of the bottom part of the triangle there. So what we're going to have to do is sort of imagine doing this as two separate triangles. So the first part, if we look at sort of the smaller triangle, so that one right there, we've got our 22, opposite side is 4. Let's find that side there as side A again, doesn't matter what we call it. So let's do that one first. So we've got adjacent and opposite, so that'll be tangent. So we'd have tan 22 equals opposite over adjacent. Cross multiply those, and this is one of those ones too, because A is on the bottom. Let's do a flip-flop. So we'll have A equals 4 divided by tan 22. So A equals 9.9. So now let's go back to our triangle again. Let me erase all that. And we know that this side that we called A was 9.9. So let's put that in there. So now what we want to do is look at the big triangle. So we have one big triangle now, that's a right angle triangle. We know this side's 9.9. We're looking for just the x, but let's solve it for the whole side. So let's call that the opposite side. Right? We want to figure out the whole length. So x plus 4 basically. And then we need the angle, and in this case our angle then would be those two angles both put together. So that would give us 37 degrees. So now solving that big triangle, we got 37 degrees, we got opposite and adjacent again, so we're going to use tangent one more time. So tan 37 equals opposite over 9.9. Cross multiply those ones, so that one's pretty easy. We can just do 9.9 times tan 37. So our opposite's going to be 7.5 if we round it off. And we're almost done the question, so we know this total side then is 7.5, but remember our original question, we just wanted the x by itself. So if the total 7.5, we just got to subtract that 4 that was given to us, so our x then is 3.5. And we're done. So that's it for today. So just some more practice questions using SOHCAHTOA and dealing with some triangles that are a bit harder. We'll be using the 180 rule and things like that a little bit later on in more questions. And that's it.